Hi, Year 11. Today we're looking at composite shapes. So shapes made up of two different things. So what we're going to do, every time we got a composite shape, we need to break it up. We're going to break this one up into a square. So here's our square, and here's our triangle. So what we're going to do, we're checking a house consists of a square and a triangle. The square has a side length of 6. The triangle is isosceles, so we know that this here is 6. We've got to use Pythagoras to find x. So here's our triangle. We got x, and we got 6, and a right angle here. So way back when we did Pythagoras' theorem, c squared equals a squared plus b squared. Here's our c. Here's our A, here's our B. So, our A is x squared, so we put our A here. Our B is x, so x squared, and here's our C. Now you'll notice that there's been an error in this one. Some silly bugger forgot to square it. So, instead of being 6, it should be 36. So we end up with 2x squared equals 18, x equals the square root of 18. Oh, I can't believe I made that mistake. What a good day. So, once we've found x, and I'm happy if you just leave it in its exact form, we go through and we find the area. So the area of the square, 6 times 6 gives us 36. Let's do this one again. So we got 18 times 18, and they're both square rooted, divided by 2. Now, here's a good part. 2 square roots exactly the same give us just that amount. 18 divided by 2, which gives us 9 meters squared. Once we've got that answer, we're going to add the two together. So we got 36, I'm going to call it area total, equals 36 plus 9, which equals 45 centimetres squared. Here's a semicircle cut out of a semicircle. Two ways to attack this one. One way would be to say that it's half an annulus. The other way would be work out the circle, halve it, work out the other circle and halve it. Let's go through and solve it. So we're going to do it this way first. So here's our semicircle. We're going to use r equals 5 for the little one. And in the big one, we're going to use r equals 10. Going back and having a look, we've got our radius of 5 for our small circle, and we've got a radius of 10. Now it's 10 because we need to cut that in half, because we only want the radius, not the diameter. So, what we're going to do, let's do it the annulus way first. Pi lots of big R minus little r, both squared. Got our formula written down. Our little r is 5, our big R is 10. Both measured in centimetres. So we got pi lots of 10 squared minus 5 squared. Now 10 squared and 5 squared are both really nice numbers. So we're going to go pi lots of 100. Take away 25, which leaves us with 75 pi, which is equal to, and again I've just written down straight from my calculator, we need it to the nearest square centimetre. We got a 6, so we're going to round it up to 236 centimetres squared. As you can see, they've made an error. They used 20. That was a bit silly. So it should be 10 squared, which gives us 100 pi centimeters squared. Now all we need to do once we're doing that is we just need to add them up. So we got 100. Let's ignore that because that's all wrong. 100 pi minus 25 on 2 pi, which equals, well, so what we've got left is we've got 50 pi minus 12.5 pi, which leaves us with 37.5 pi, which is equivalent to, which equals 118 centimeters squared. Right. Simpson's rule, we'll talk about that next lesson.